Hey Tony, I brought the supplies. None of these work anymore.
The painkillers that Tony has been taking after his surgery no longer produce the same relief they used to provide. Instead, the pain prevails, seemingly not responding to the drug anymore. And this is by no accident. What Tony is experiencing in this situation is called tolerance, which is defined as a decrease in the therapeutic effects of a drug after repeated prolonged use. In simple terms, a person gets so used to a drug that the effects of it diminish over time, requiring that individual to increase their dosage to feel the effect again. Although a process that seems counterintuitive at first, tolerance is essentially the body's way of protecting itself and restoring balance. Tolerance can be divided into two categories, innate and acquired. However, in today's lesson, we'll mainly focus on acquired tolerance. Acquired tolerance is a result of repeated drug use and can fall into three types: learned, pharmacokinetic, and pharmacodynamic. This process occurs when an individual learns how to adapt their behavior to the effects of a drug to overcome it. In other words, they acquire the skill of compensating for the drug's effects to appear somewhat high functioning, despite the concentration of the drug present within their system. Is a process in which the body increases the production of metabolic enzymes so that lower amounts of the drug are able to reach the receptors, which helps diminish the effects. Finally, pharmacodynamic tolerance is when the receptors grow accustomed to the drug, so that the ability to induce a cellular response is ultimately minimized. In Tony's case, he was prescribed opioids to manage the severe pain after surgery, yet weeks of using painkillers such as morphine seemed to no longer work as efficiently as they did in the beginning. What type of tolerance is Tony experiencing in this situation? The answer would be pharmacodynamic tolerance, and this took place to restore homeostasis. Here is how. When opioids such as morphine cross the blood-brain barrier, they bind to mu-opioid receptors, which are located throughout the central nervous system and are characterized by functions such as assisting with pain management. In order to reduce the sensitivity of these receptors, they become phosphorylated, which means that a phosphate group is added to the receptor to change its function. In Tony's case, the mu-opioid receptors became phosphorylated to become desensitized. After this occurs, proteins called arrestins are recruited to bind to the receptors to block G protein signaling, which prevents the receptor from coupling to G proteins and induces receptor endocytosis by internalizing the receptor into the cell. These actions lead to downregulation of the receptors, as most of them are removed from the cell surface. Over time, the brain adapts to this process by setting a new normal that includes the effects of the drug, resulting in tolerance. Thus, it looks like Tony will need a higher dose.